RHS Pre-Calculus presents
Complex Numbers. Welcome to Simply Complex Numbers. Now your fantasies become reality and your reality is fantasy.
Have you ever tried to solve a problem and had a negative number under the radical? Do you not know what to do because you know you can't take the square root of a negative number? Well, there is a solution.
To solve a problem where x equals the square root of -1, mathematicians created an expanded system of numbers using the imaginary unit I. They decided that the square root of -1 would be equal to I.
Oftentimes you will see this imaginary unit taken to some power. These terms can also be solved from what we know already. If I is equal to the square root of -1, then I squared is equal to the square root of -1 times the square root of -1, which equals -1. Following suit, I cubed is just the same as I squared times I. So if I squared equals -1, then I cubed is equal to -I. Similarly, I to the fourth is the same as I squared times I squared. And if I squared equals -1, then I to the fourth equals 1. Now luckily there's a pattern here. Since I to the 0 is 1 and I to the fourth is 1, the pattern repeats every 4 powers of I. So I to the fifth is going to be the same as I to the first, or I.
Now this is getting a little complicated, so I think we need some diagrams here. Here we have a Komodo dragon. Think of it as a real number. And here we have the square root of a -1, also known as I. Normally these two wouldn't get along, but with this new math concept, when we multiply this Komodo dragon by I, we get a dragon, which is an imaginary animal. Now let's look at another example. Here we have a horse. When you multiply a horse, something real, by I, we get a unicorn, something imaginary.
Now, things are going to get a bit more complex. In many situations, you'll have numbers which are, you have real numbers, which are numbers that can be put on a number line, and imaginary term I in the same term. We call these numbers complex numbers. The standard form of a complex number is a plus bi, where a and b are real numbers and I is used as the imaginary unit discussed earlier.
Now that we know what complex numbers are, we can demonstrate how to add and subtract them from each other. When adding and subtracting complex numbers, combine like terms. So in the addition problem, the 1 and the 5 are the real terms. When added together, they get 6. The imaginary terms, 6i and 9i, when added together, get 15i. In subtraction, you do the same thing, except for instead of adding the numbers, you would subtract them. So the real terms, 2 and 7, when subtracted, 2 minus 7 would be -5. And 6i minus 9i would be -3i.
Now that we know the basics of adding and subtracting complex numbers, we can multiply them as well. Multiplying is easy, since it will involve at least 2 separate terms and can be solved by foiling. Here we have 1 plus 4i squared, which is the same as 1 plus 4i times 1 plus 4i. To solve this problem, we're going to FOIL and then combine like terms. After FOILing, you get 1 plus 8i plus 16i squared, which is the same as 1 plus 8i plus 16 times -1, since I squared is equal to -1. After combining like terms, the final answer is -15 plus 8i.
So let's review. In this video, we covered what complex numbers are, a real number coupled with an imaginary term in the standard form a plus bi, how to add and subtract complex numbers, remember to combine like terms, as well as the basic powers of I. Thank you for your time, and I hope you enjoyed your trip into the imaginary land of complex numbers.